Good morning, afternoon, or evening, cats and dogs. Today's video is going to involve solving one-step equations by adding or subtracting. At this point, we've already talked about how we identify inverses for adding and subtracting statements. We've also mentioned the addition and subtraction properties of equality, which basically say that whatever you do to one side of an equation, you also need to do to the other to keep your equation balanced. So we're going to use our inverse operations and the addition and subtraction properties of equality to help us solve one-step equations by adding or subtracting. So let's take a look at problems 1 through 18 to start. So in the exercise problems, it says to solve each of the following equations, show your inverse operation and any side work. Now, you're allowed to use calculators for this unit and for this lesson, so you probably don't need to show the work off to the side, but you will want to use your calculator to double check answers if you're calculating them mentally. So let's take a look at number 1. Again, go back to that lesson and think about that lesson that we talked about where we identified what was happening to the variable and the inverse. That's what we're going to be using and applying here today, taking it a step further from our previous lesson. So if we have an equation like x plus 12 equals negative 5, the first thing you want to do is identify what's happening to the variable. Remember, that's this WHTTV. What's happening to the variable in this equation is that we're adding by 12. So the inverse of adding by 12, remember we have two possible inverses. One inverse is to subtract by 12. The other inverse is to add by negative 12. We can change either the operation or the sign, but not both. So I'm going to write that inverse once on each side of my equal sign or each side of my equation. We can either show subtract by 12 or plus a negative 12. You don't have to show both, but both will work. So again, we always show our inverse on both sides of our equation, and I'm going to highlight this in blue for us. So either subtract by 12 or add by negative 12, show it once on each side of the equation. On the side with the variable, that should cancel out because 12 minus 12 is 0. So you get x plus 0. Now, I don't normally write this step, and you don't need to write it either. But what you do need to calculate, and you can use your calculator to do this, is negative 5 plus negative 12. Negative 5 plus negative 12 gets us negative 17. So my solution is x equals negative 17. One way you can check your solution is replace x with negative 17. Do negative 17 plus 12, hit equals. As long as your calculator gives you negative 5, it means that your solution is correct. Be aware that for right now, we're going to write this WHTTV, the what's happening to the variable and the inverse. But I hope that you'll be able to get to the point where you can do that process mentally without having to write it down. In fact, we'll eventually get to two-step equations and one and two-step inequalities as well. And by that point, I don't expect you to have to write this out every time. So let's take a look at number 2. Negative 18 equals g minus 26. I forgot to cover this up, but what's happening to the variable is we're subtracting 26. The inverse of subtracting 26 is to add 26. So I'm going to show plus 26 once on each side of my equation. Again, always the inverse is what we show. On the right-hand side, we're going to be left with g. On the left-hand side, I need to calculate negative 18 plus 26. Go ahead and try that. Hopefully you get a solution of 8. So our final solution is 8 equals g. And it's okay to leave it as 8 equals g. You can also rewrite it as g equals 8. We just want to be careful about doing that once we get to inequalities later on. All right, let's move ahead. And there's no harm in you trying some of these problems ahead of time on your own. Just make sure you double check your solutions. So number 3, we have negative 14 plus y equals 31. What's happening to the variable here is we're adding negative 14. I know it's written backwards, but we're adding negative 14 to y. The inverse of that is to add a positive 14. Now you could also subtract a negative 14, but you'll get used to figuring out which inverse maybe is a little easier to work with. I think adding a positive 14 is a little easier. So let's add 14 to both sides. On the right-hand or on the left-hand side, this is going to cancel out, and we're going to be left with just y. What you're going to plug into the calculators is 31 plus 14, and that will get us a solution of 45. So our final answer will be y equals 45. All right, for number 4, I do suggest you start by rewriting this as z plus 29. That's just an easier equation to deal with. You could leave it as subtract a negative subtracting a negative 29, you'll get the same inverse, but I just think z plus 29 is easier to identify what's happening to the variable and the inverse. So what's happening to the variable when I add the opposite is add by 29. The inverse of that is subtract by 29. So let's show subtract by 29 once on each side of our equation. And what you're going to plug into your calculator, make sure you work top down, is negative 74 minus 29. Go ahead and plug that into your calculator. What do we get? If you got z equals negative 103, you are correct. Again, negative 74 minus 29. Don't forget, you can double check your answer. Do negative 109 minus negative 29. Hit equals. If your calculator gives you negative 74, it means your answer is correct. All right, number 5. H minus 62 equals negative 36. What's happening to the variable is we're subtracting by 62. The inverse of subtracting by 62 is to add 62. So let's add 62 one time on each side of our equation. Again, on the left-hand side, you'll just be left with h. On the right-hand side, you're going to do negative 36 plus 62. You will get h equals 26. Number 6 is already done for you. Again, what's happening to the variable is add by negative 18. The inverse of that is to add by 18. Show it once on the left and right. Plug in 27 plus 18 to get 45 for your solution. I do like to throw in some questions already done for you periodically just so you can see those. All right, let's move right ahead to number 7. Negative 55 equals r plus 49. I did have a student ask last week who was doing a similar type of problem. Can I write this as r plus 49 equals negative 55? Absolutely. What's happening to the variable is we're adding by 49. The inverse is to subtract by 49. Or add a negative 49 also works. So let's subtract 49 from both sides. On the right-hand side, this will cancel out, leaving you with r. What we're going to plug into our calculators to get our solution is negative 55 minus 49. Go ahead and do that. Hopefully you got a solution of negative 104 equals r, or r equals negative 104. All right, number 8, negative 78 plus a equals negative 38. What's happening to the variable is plus negative 78, even though it's backwards. The inverse is to add a positive 78. So we're going to add 78 to both sides. And in your calculator, you're going to plug in negative 38 plus 78. That's going to get you a equals 40. All right, number 9, f minus 27 equals 39. What's happening to the variable is subtract by 27. The inverse of that is to add 27. So let's show plus 27 on the left and right. This should be becoming really standard for you, and it'll get easier with practice. In your calculator, plug in 39 plus 27. What do we get? Hopefully you got a solution of f equals 66. All right, number 10, just like our previous problem like this, I would rewrite it as e plus 22 equals negative 51. What's happening to the variable is plus 22. The inverse is either to subtract 22, or I made things more interesting here, and I did plus a negative 22, but subtracting 22 will also work. So let's show our inverse one time on each side of the equation. And we're going to do negative 51 plus negative 22 to get our solution, and we'll get e equals negative 73. Again, negative 51 plus negative 22 to get your answer, or negative 51 minus 22 also works. All right, moving right along. Number 11, let's mix in some decimals. Why not? We've got negative 14.8 plus g equals negative 26.1, or 21.6. Goodness, flip-flopped those. What's happening to the variable is we are adding negative 14.8. So the inverse is to add a positive 14.8. So add 14.8 to both sides. And in your calculator, you're going to plug in negative 21.6 plus 14.8. Practice plugging this into your calculator to make sure you know how to do it. All right, hopefully you got a solution of g equals negative 6.8. These are really important to check your solution. So do negative 14.8 plus negative 6.8. Hit equals. It should give you negative 21.6. Number 12. What's happening to the variable is we're subtracting 18.21. The inverse is to add 18.21. So let's show that once on each side of our equation, on the left and on the right. On the left, everything's going to cancel out except for the d. In your calculators, plug in negative 14.6 plus 18.21. These are especially important to double check in your calculators. You should get a solution of d equals 3.61. All right, question number 13. We have negative 4 and 3/4 plus g equals negative 2 and 5/6. Let's mix in some fractions. What's happening to the variable is we are adding negative 4 and 3/4. The inverse is to add a positive 4 and 3/4. So show plus 4 and 3/4 on both sides. Again, keep in mind, I know we're going to be virtual here for this week, but if there are things you have questions about in terms of plugging mixed numbers into your calculator, please ask. I can help. It's a little harder during a live Zoom session, but we can always help you figure out how to plug this in. I can also show you when we return to the classroom. So in your calculators, you should be plugging in negative 2 and 5/6 plus 4 and 3/4. And you should get a solution of 1 and 11/12. If you're not getting that or it shows up as an improper fraction, there are ways to get around that and I can help you. Just let me know if you're struggling with plugging that in. All right, number 14. We have y plus 3 and 1/5 equals negative 5 and 4/9. What's happening to the variable is plus 3 and 1/5. The inverse of that is to subtract 3 and 1/5. So we'll show that once on the left and on the right-hand side, subtracting 3 and 1/5. And again, be careful plugging this into your calculator. You're going to be doing negative 5 and 4/9 minus 3 and 1/5. Make sure you're using the negative key for a negative fraction and the subtraction key for subtracting. I've had some students mixing them up. I know they look the same here, but this is a negative 5 and 4/9 minus 3 and 1/5. If you use the wrong key, your calculator might give you an error message or the incorrect solution. We should end up getting y equals negative 8 and 29/45. This is where it's really important to have a calculator. It's much more challenging to do if you don't. All right. I do have some independent practice problems I'd like you to try. So pause the video, give these 4 questions a try, and we'll look at the solutions here in just a couple of moments once you restart the video. All right, so hopefully you've done questions 1 through 4 at this point. For problem number 1, we have u minus 19 equals negative 37. You're going to notice that I'm not showing the what's happening to the variable or the inverse operation here, just because I think at this point you might be able to get away from showing that. So mentally, you should be thinking, I'm subtracting 19. So the inverse of that is to add 19 to both sides. When we do that, you'll end up getting, and you'll plug into your calculators, by the way, negative 37 plus 19, which will get you negative 18. All right, number 2, again, what's happening to the variable is add 26. So to undo that, we're going to subtract 26. In your calculators, you should have plugged in negative 45 minus 26, and you should get a equals negative 71. Number 3, what's happening to the variable b is we're adding negative 17.2. So let's add a positive 17.2 to both sides. In your calculators, you're going to plug in negative 6.7 plus 17.2, and you will get a solution of b equals 10.5. Finally, number 4, we're adding 4 and 3/4, so the inverse of that is to subtract 4 and 3/4. In your calculators, you want to do negative 2 and 1/3 minus 4 and 3/4, and you should get a solution of negative 7 and 1/12. So hopefully you did pretty well on those. I will tell you that the adding and subtracting problems are a little bit more difficult than the ones with multiplication and division, but we will eventually mix both operations together for 1-step and also in 2-step equations. All right, I want to finish this video by taking a look at a few word problems, so just a handful. Numbers 15 through 18, these are our last 4. So these problems are getting us started with more complicated word problems. They ask us to translate each of the following sentences into equations. So number 15 says the sum of a number and 12 is negative 18. We've already done this with numerical expressions and algebraic expressions, so we're just building on that. So let's just translate this word for word. The word sum means addition. So I know I'm going to have a plus sign here. Not a 6, but a plus sign. The number is going to represent my unknown in this case. So I'll use a variable like n to represent that. So the sum of a number and 12, obviously this is the number 12. The word is generally is going to represent your equal sign. So I'm going to put an equal sign right up here. So if I say the sum of a number n and 12 is negative 18, that's going to look like n plus 12 equals negative 18. All right, number 16. The difference of a number and 7 is negative 11. The word difference means subtraction. So I know that I'm going to have subtraction here. The number, again, is my unknown, so we'll highlight that in green and put an n here. Any variable works, though. The word is we see right here represents our equal sign. Let's go ahead and type that in. So if we put this all together, the difference of a number and 7 is n minus 7 is equals negative 11. Make sure you don't write it as 7 minus n. If it says the difference of a number and 7, the n has to come first. All right, number 17 is sort of backwards way we have it written. 16 is, so I've got 16 equals, and then 10 less than a number. Hopefully you recognize that less than is going to represent subtraction, but we did talk about something special with the words less than, or that phrase. And then the number is our unknown again. So I'll continue with the variable n. So if I say 16 is 10 less than a number, I can write 16 equals n minus 10, not 10 minus n. If you want to write it as n minus 10 equals 16, that's fine too. But remember, when it's 10 less than a number, it means I need to take 10 away from a number. Finally, number 18, negative 25 is. Remember, the word is represents our equal sign. 18 more than. The phrase more than is going to represent addition for us. These are phrases we've seen before. More than a number, again, a number represents our unknown in this case, so the variable n. So we're going to write this as negative 25 equals 18 plus n. So let's go ahead and get started. I realize that word problems are probably not your favorite type of question. They're not mine either, but they are important problems for us to be able to find the solution to, because most real life problems are word problems. Number 19 says, Jessica downloaded 54 songs onto her iPod. It's a little outdated of a question. If you don't know what an iPod is, ask mom or dad. They could probably tell you. This is 17 less than the number of songs that Kayla downloaded earlier. Now, the two boxes here are just some things we'll fill in once we talk about parts A and B. Part A says, write an equation to represent this situation. B, solve your equation from part A to find the number of songs that Kayla downloaded. So one of the things that students come to me a lot with is questions about word problems. And they'll say to me, I don't know what to do. I don't know where to start. And they will have nothing written down. I do always suggest you begin by identifying your unknown, or the thing that you're trying to find. So in this question, the thing that we're trying to find, and I'm going to highlight this in blue, is the number of songs that Kayla downloaded. It's always going to say somewhere within the question, either in the question itself, in parts A or B or C, or however many parts you have. It's going to say find this or determine this. And in this question, it says find the number of songs that Kayla downloaded. So in this box where it says what is the unknown, our unknown is the number of songs that Kayla downloaded. I chose the variable K to represent this. You can choose S, but I always want to start by defining that. So if you come to me and say, I don't know how to do this word problem, I'm not sure how to approach this, I'm going to say, well, what are you trying to find? And start by defining a variable to represent that. Now what we're going to do is we're going to break down the rest of this information. So in the second sentence, it starts with the word this. This is referring to something. What is it referring to? If you recognize that this is referring to the 54 songs that Jessica downloaded onto her iPod, you are correct. So the word this is actually referring back to this value right here, the 54 songs. We know that that value, 54, is. The word is, and I know we already talked about this at the end of our last video or during class, we talked about the word is representing equals, or our equal sign for our equation. So 54 is, 54 equals, 17 less than. We've seen the word less than multiple times. Less than represents the operation subtraction. I'm going to make this a little bit bigger so we can see it. But less than represents subtraction for us. So 17 less than the number of songs that Kayla downloaded earlier. That happens to be all of this stuff right here is the variable that we defined, which is K. So I'm going to type in a K right over here. So I don't normally do this part right here where it says to write this equation as a sentence. I do always define my variable to represent my unknown. When it says to write this equation as a sentence, if you remember to the first part of this lesson, the previous questions, numbers 18 and 17, 16, 15, I think there were only 4 of those. We had sentences versus like, you know, a problem and then a part A and a part B. So what I want to do is translate all of these words into just a sentence. So what I'm going to write is 54 is 17 less than K. And that's what we have here. 54 is 17 less than K. So let's represent this then as an equation. 54 equals K minus 17. Please keep in mind that if we say 17 less than K, it means we need to take K minus 17. We need to take 17 away from K. This is the hardest part, is writing the equation. Once we write the equation, we just solve it like we solve a one-step equation. So what's happening to the variable is we're subtracting 17. The inverse of that is to add 17. So we'll add 17 to both sides. I'm not going to write the what's happening to the variable and inverse off to the side. We'll go through that process mentally. So all we have to do is 54 plus 17, and this is going to get us a solution of 71. I do like to label my answer. While you don't need to write a sentence, I would ask that you at least label your answer with the word songs. So how many songs did Kayla download? She downloaded 71 songs. All right, so let's take a look at another problem that's really similar to this, question number 20. Number 20 says, the Jefferson Memorial in Washington, D.C. is 129 feet tall. This is 30 feet taller than the Lincoln Memorial. A, write an equation to represent this situation. B, solve your equation from part A to find the height of the Lincoln Memorial. So for this one, we want to start by defining our unknown. In this case, it says, find the height of the Lincoln Memorial. I chose h to represent height, but you can choose any variable you want, so I wrote h equals height of Lincoln Memorial. In our first sentence, it tells us that the Jefferson Memorial is 129 feet tall. And we know that that value is going to be, so the 129 is, by the way, is going to represent our equal sign, 30 feet taller than. In this case, when we see the word taller than, that's going to indicate addition to us. Now, yes, subtraction is an inverse operation, so we're going to use subtraction to solve this, but taller than means plus. So 30 plus, and then the height of the Lincoln Memorial, well, that represents our unknown, as we already stated. So this is going to be my variable h. So 129 is 30 plus h. 129 equals 30 plus h. Now, I have seen students write this as 129 minus 30. They recognize they need to subtract the two numbers to get their solution. That's fine, but you definitely need to make sure to write it as 129 minus 30 equals h. If it asks for an equation, you have to make sure to write an equation and not just an expression. So let's go ahead and solve this. The inverse of adding by 30 is to subtract 30. So we do that once on the left and the right. 129 minus 30 gets us a height of 99. I did write a sentence, but keep in mind you just need to label your solution. In this case, we know that the Lincoln Memorial is 99 feet tall. All right, so we solved 2 problems that are really similar. Let's take a look at another 2 problems that are very similar to one another. Number 21, during the night, the temperature dropped 14 degrees to negative 9 degrees Fahrenheit. A, write an equation to represent this situation. B, solve your equation from part A to find the temperature at the beginning of the night. Let's start with the thing we're trying to find. It says find the temperature at the beginning of the night. So I believe I used T to represent that. Let's see. Yeah, T represents the temperature at the beginning of the night. We have the word dropped within this problem. What operation does that indicate for us? If you're thinking subtraction, you're correct. So it says during the night, the temperature. This part right here actually represents our unknown. That was the temperature at the start of the night, T. It dropped, which represents subtraction for us, as we already stated, 14 degrees. So we're going to take T minus 14. And then it says 2. It doesn't use the word is in this case, but if it dropped to that value, where it ended up is what we're going to set this equal to. So if we just kind of translate this word for word, just like we would translate from one language to another, we're going to write T minus 14 equals -9. Temperature starts at T. We take away 14 degrees. By the end of the night, it's at -9 degrees. Let's solve this. The inverse of subtracting by 14 is to add 14. So you're going to do -9 plus 14, and we get T equals 5. I do want to put a label on this. It'll be 5 degrees Fahrenheit. You don't need a sentence, but a label is definitely helpful here. Now, there are other equations you could write. So if you have T equals -9 plus 14, that's fine. I've seen students write T equals 14 minus 9 as well. I mean, that could also work. If you write an equation that's equivalent to what I have and you have the correct solution, you will get full credit. Now, I have seen students write 14 minus T equals -9 and still end up getting 5. That equation is not equivalent to T minus 14 equals -9, so you wouldn't get full credit for something like that. All right, number 22 is really similar to number 21. I always like to give you more than one question on the same topic, just kind of shift gears a little bit in terms of what we're discussing, but it's another temperature question. So number 22, it says the difference between the record high and low temperatures in Anchorage, Alaska is 124 degrees. The record low temperature was -38 degrees Fahrenheit. A, write an equation to represent this situation. B, solve your equation from part A to find the record high temperature. So once again, let's identify our unknown. In this case, it says find the record high temperature. So I chose H to represent that for record high temperature. We also have the word difference in this problem. And what operation does the word difference indicate? We've talked about that before. Hopefully you recognize that that means subtraction. So differencing the record high is our unknown, H. And low temperatures, they actually tell me the low temperature. I'm going to highlight this in purple here. The record low temperature was -38 degrees Fahrenheit. So that is this right here. I'll highlight that in purple also. So the difference between the record high H and the low temperature -38 is, that's going to be my equal sign, 124. So let's translate this. We have a record high H minus our record low, -38, equals 124 degrees. Let's solve this. I do suggest when we solve problems like this before, rewriting this equation as H plus 38 equals 124. Now subtract, that's our inverse of addition. Subtract 38 from both sides. We're going to get H equals 86. It means that the record high temperature is 86 degrees Fahrenheit. Make sure it makes sense, because if you add 38 to 124, you end up getting a record high temperature of 162 degrees. We're not talking about the middle of the desert here. We're talking about Anchorage, Alaska, which is closer to one of the poles. So we really want to make sure that that record high temperature is reasonable. 86 makes a whole lot more sense than 162 degrees. All right, so number 23 kind of goes hand in hand with problems. I'm going to go back to these 19 and 20. So if you're looking at problems to refer to help you with question number 23, I do suggest going back to those two questions, 19 and 20. Let's read through this. There are two different routes for the Iditarod Trail Sled Dog Race. During the odd years, the race takes place on the 1,161-mile southern route. This is 49 miles longer than the northern route that takes place during the even years. Which equation can be used to find the length of the northern route? So while this is multiple choice has a tendency to be the area where students struggle. Ignore the answer choices. Let's go through and try to answer this ourselves and see if we can find one of the answer choices that matches with our solution. So let's identify our unknown. We are trying to find the length of the northern route. So I'm going to define a variable for that. N equals the length of the northern route. All right, let's go back to this problem. It says, On the odd years, or during the odd years, the race takes place on the 1,161-mile southern route. This is referring to the 1,161-mile southern route. So 1,161 is, remember, is represents our equal sign. So it's going to go right here. 49 miles longer than. Hopefully we recognize that longer than means addition. The northern route. Well, the northern route is our unknown. We don't know the length of the northern route. So this is our variable n. So let's break this down. Let's take out all that extra information that we don't need. So 1,161 is 49 miles longer than the northern route. So let's write that. 1,161 equals 49 longer than is plus our northern route, which is n. Let's go back and see if any of these match this. Letter A. Yeah, this one does match. Now, it's written as n plus 49, but remember addition is commutative, so choice A is the correct solution. Let's look at the other options. I want to point out I've had students choose both B and C for a problem like this. Here's the thing, both B and C would get you the exact same solution, which means they're equivalent. Since we only have one correct solution, it wouldn't be possible for B or C to be the answer, because if B is the answer, then so is C. If C is the answer, so is B. So neither of these is correct. It's really tempting to maybe pick choice C because longer than means addition, but we're actually going to subtract 1,161 and 49 to get our solution. Part D, sorry, not part D, but letter D, I've had students choose letter D in the past, and letter D also does not make sense because you would solve this by subtracting 1,161 from both sides. And if you subtract 1,161 from 49, you get a negative value. And remember that n represents the length of the northern route, so it cannot be a negative value. So you definitely want to stop and think about this a little bit as you're working through the problem. The only one that makes sense here is letter A. All right, so I want to finish here with question number 24. Sorry, I went a step ahead. Number 24 is an extra challenge question. This is the last problem we're going to see before moving on to a new topic. Now, we will review some word problems in class as well, since I know it's something that students sometimes struggle with. So number 24 says, if a number x satisfies x minus 12 equals negative 15, find the numerical value of 4x minus 8. So a lot of students will ask me, what does this word satisfies mean in this case? Well, it means a number x makes that equation true. So let's solve for x and figure out what x will be, what value of x satisfies that equation, which again means it makes it true. So the inverse of subtracting by 12 is to add 12. Negative 15 plus 12 is going to get us x equals negative 3. So we know that x is negative 3. It asks us to find the numerical value or number value of 4x minus 8. Well, let's replace x with negative 3. So we'll do 4 times negative 3 minus 8. 4 times negative 3 is negative 12. Subtract off 8 gives us negative 20. And you can use a calculator for that. So what do we get from this? Well, we had two different types of word problems here. This is more than or less than something else. So that was 19, 20, and then 23. And we also had the problems where we were subtracting two values and we set it equal to some total or some final value. So those are the kind of problems you can expect to see on a quiz, a test, or in class. Thanks for listening.